Hi guys, nice to meet you again. And we'll continue our discussion on option. Um, and this is the fourth part of our video series on derivative markets and instruments. And you might notice that in the third part of our video series, we have talked a lot about the mechanisms of option trading and also the profit and loss characteristics, and also the option pricing models using the Black and Scholes option pricing model and also the binomial model. So in this section, in this part, we'll continue with the hedging mechanism using option, right? And uh, the hedging mechanisms would be used to hedge the interest rate risk and also currency or foreign exchange risk, and also the credit risk. Okay, so let's go straight into our materials. Okay, okay, so bond option, this is the first one. And yeah, most of the time, this is to hedge against the interest rate risk, right? Especially if you have a long position in bond or bond portfolio, uh, you'll be very unhappy to see an increasing market interest rate or an increasing yield, right? Because if the market interest rate increases, then uh, the value or the price of your bond will decrease, right? And so will your portfolio value, especially your bond portfolio. So increasing interest rate is identical with decreasing the value of the bond or decreasing bond price. So uh, we have seen the third part of the video how uh, this changing interest rate, especially increasing interest rate, uh, affects the price, and then how to deal with it, right? Using the option, right? It's also similar logic that we did or we use for a forward and futures contract. But this part, or right now, we are going to see how to do the hedging for the whole balance sheet. Right? So it's more like macro hedging. Right? So in the third video, we saw the micro hedging. Again, in the fourth part, we'll see more about the macro hedging, right? The whole balance sheet. Before that, we see examples of quotations or quotes, right, for the interest rate futures. And this is uh, even futures options, right? If you notice, so futures options. So these are option contracts on futures. So you can imagine the development in financial engineering, right? In the derivative market, one as one of them. So every day, with the advancement of modern technology, right? The information, communication, and technology, information and communication technology, uh, we can produce like almost every day, or even maybe more than once a day, new instruments by combination, right? With different, payment characteristics and also risk characteristics, and so forth, right? See here, we're talking about futures options. So these are option contracts on futures. As we know, futures itself is a derivative instrument, right? An option is another derivative instrument. When we have futures options, it means that these are the option contracts on futures, right? So it's like second layer of derivative instruments. Okay, so let's go straight into the first one. This is again the macro hedging to hedge against the balance sheet, right? The balance sheet risk, especially related to the change in equity value. So we have talked about this over and over again. If if it happens that you are not familiar with this configuration, please watch my video on interest rate risk. Okay, we talk a lot about this as the foundation of further discussion on the interest rate risk, especially how the movement in interest rate could affect your equity value or the change in your equity value. Okay, so here can you see this is the duration of your assets, the weighted average, right? And then this is the duration of your liabilities, and K is the debt ratio, A is your asset size, and this is the change in interest rate divided by 1 plus the original interest rate, the market rate, of course. Okay, so let me write down to make sure. Okay, so you are quite concerned that something will happen to the value of your equity, right? So once again, this would be a function of minus, right? So duration of your assets. This is weighted average, right? Weighted average of uh, your assets duration. So it's like the weighted average value of the your assets durations minus duration of your liabilities, but you multiply it by the debt ratio, right? Multiplied by the size of your assets, and then times the change in interest rate that you are concerned about or you are afraid of, divided by 1 plus the original market rate. Okay. So now by using option, right? By using option, uh, you see, this is the change in the value of the option. So we try to match it, right? So in I think the second part of the video series, you saw how we did this for forward or futures contracts, right? So we try to match if something happens to your equity value, so there's a change in your equity value, it should be matched with the change in the derivative instrument value. So in this case, it's option, right? See, this is the change in option value. The change in option value is a function of the first one is called, see, the DP, right? So DP is the change in the option value uh, with respect to the change in uh, the bond value, the underlying bond value. So remember, we have two different things, right? Uh, in our real business, we have our bond portfolio, right? We have assets in the form of bonds. We have liabilities in the form of bond issuance, right? But this bond is the underlying asset that we are using as a basis of the contract. So you go to the derivative market, you see one or two or certain bonds, then you use that one as a basis for your derivative transaction. So this is the underlying bond, right? A DP, also this is the change in the option price divided by the change in the bond price. So the change in the option value per $1 or yeah per $1 change in the bond value. So this is called the delta of the option. Okay, so once again, this is the change in the option value per $1 change in the underlying bond value. Right? And of course, this one, so it's quite familiar. DB, again, a B here is the underlying bond, not the what's it the bond portfolio that we are having on our balance sheet. Okay, so you still remember when we talk about this in the interest rate risk, right? Maybe I'll write it down here. Now the change Change in the option value is a function of the delta, right? Delta of the option. So delta of the option is the change in the option value per $1 change in the underlying bond value, right? Okay, so if we multiply this one by again the dB dr, okay, multiplied by the change in the market interest rate. So this again, once again, this is called the delta of the option. So now this one, I hope you are familiar after watching the interest rate risk video. So I hope you still remember we were talking about this, right? This is underlying bond, okay? So this should equal what? Duration of the bond, right? Duration of the bond multiplied by the change in interest rate plus 1 plus the original interest rate. Okay, so if you move it here, right? I can move it here. Or maybe I move it a bit far. Okay, I'll move it here, from here to here. Okay. Okay, and then I can move this one here. Got it right? So I move this one here. Okay, that's why you see here, dBdr, yeah, dBdr. Okay, so I hope you still remember. Duration of the bond divided by 1 plus the original interest rate is called what? Modified duration, right? This is the modified duration. So maybe I can write it here. So it should equal, so dBdr should equal minus modified duration multiplied by the size of the bond or the value of the bond right now. Okay, so and then multiplied by the change in interest rate, right? Change in interest rate that you are concerned about. Okay, so so once again, now we try to match the value, right? Match the value. But beforehand, let's finish this one. So, yeah, we got this one, right? Okay, so maybe we'll do it. We'll extend it here. So this should equal what? Delta of the option at dp, and the change in the option, option value per $1 change in the bond value. Again, this is the underlying bond, right? And then this one now we try to extend extend it. So we got it from here, right? This one, right? So uh, this one, then minus d, right, divided by 1 plus original interest rate multiplied by the value of the bond, right? And then this one, okay, okay. Of course, I can move this one here, right? We'll do it. Okay, I'll move this one here. Okay. Okay, so this is the here you see uh, the change in the option value, right? Change in the option value, and of course, in terms of the total impact of the derivative transaction, we have to multiply again the change here, this one, right? The change in the option value multiplied by the number of the option, right? Number of the option contracts uh, taken, right? Number of the option contracts bought or sold, right? Uh, whether we take the long or short position, okay? So again, the change in the option value is then multiplied with the number of the option contracts taken. Okay, so now we try to combine them, right? So once again here, so we could write it down like this, right? So the number of the option contracts, right? Either long or short position, either call option or short option, right? Multiplied by, and what is it again? The Here you see delta of the option. So delta of the option is dp/db, right? Multiplied by minus duration, okay? Multiplied by the value of the underlying bond multiplied by the change in interest rate divided by 1 plus the original interest rate. Now here's the thing, right? If you are taking, if you have a long call position, then the delta of the option would be positive. You could imagine, right? This is uh, the change in the option value per $1 change in the underlying bond value. So if this is a call option, the delta of the option would be positive. However, if you're taking a long put position, right, long put position, then the delta of the option should be negative, right? Because now uh, you you have the right to sell something, right? You have the right to sell the underlying bond. If the underlying bond decreases in value, then you earn more money. But on the other hand, uh, if the underlying bond increases in value, your option would be worthless, right? It will end up worthless. Okay, so depending on the contract that you are taking, if you are taking uh, a long call position, then the delta of the option is positive. But if you are taking a long put position, then the delta of your option would be negative. Okay, so it depends on the story, right? Okay, so following the story here, we have to adjust to our story right now. You have the bond portfolio right on your balance sheet. Again, this is not your underlying bond, okay? Your the bond on your portfolio, and yeah, you fear for the decreasing values of the bonds, right? So obviously, you take the long put position, very long put position because you're afraid of uh, the decreasing value of something, in this case, your bond portfolio. So you're trying to long put, right? Long put an underlying bond. So in our story here, if this is long put, then this should be negative. So I have to be careful. Again, if you're taking a long put position, this would be negative. See, negative multiplied by negative, this would be positive, right? So with the long put situation, it would look like this. This is the delta of the option multiplied by the duration, multiplied by the bond uh, underlying bond value or size, right, multiplied by the change in interest rate plus 1 plus original interest rate. Okay, so both become positive because here we have the negative and negative. This is for long put situation. But once again, if this is long call, then the delta of the option is positive. But again, in our story, we try to hedge against decreasing bond portfolio value. So obviously, we have to take the long put position, right? Because we try to lock in the value. If the value decreases, we have the right to sell at a higher price. So we will gain profit from the derivative transaction. Okay, so now we will combine the story, right? If we lose something here, we want to gain it from here. Derivative, right? In our story here is the option, right? Okay, so whatever notation you want to use, maybe big P. Okay, so what is it again here? It's minus, uh, but here minus, right? Duration of assets minus duration of your liabilities, right? The debt ratio multiplied by your assets. Okay. See here, if you lose something, right, in your equity, so this one is minus. So we have minus here, we might have minus here, we end up having what? Positive value, right? I hope you follow, right? So here minus, minus and minus, so they will end up positive. Okay. Now, again, the decrease in your equity value should be compensated with the increase in your this one, right? Okay, so this should equal number of put option to be taken, right? Multiplied by again the delta of the option. dPdB is the delta of the option, right? Multiplied by the duration of the underlying bond multiplied by the size of the bond, underlying bond. Okay, be careful. And then here, right? Change the interest rate divided by 1 plus the original interest rate. And for now, we assume that there's no, what's that? No difference between the change in the interest rate for the main business and the change in the interest rate for the underlying bond. So there's no basis risk, okay? So first, we assume that there's no basis risk. So we can erase both because they're the same for now. Okay, so we just need to now rearrange the equation. Right? So the number of put option contracts to be taken should equal something like this, right? Now very easy. Okay, divided by delta of the option, dPdB, multiplied by the duration of the underlying bond multiplied by the size of the bond. Right? Okay, so we got that's why we got this equation. Okay. Okay, so let's see an example now. Now it's getting easy. Duration of the assets is 5. Duration of the liabilities is 3. K is the debt ratio, okay? Debt ratio, 90%. L per A, right? The asset size is 100 million. So this financial institution is concerned or is afraid of increasing interest rate from 10 to 11, okay? So an increase by 1%. Okay? Okay, and if this happens, it has been estimated that the equity will decline by 2.09 million. So you find something here, you find an option contract. So the delta of the option, see here, delta of the option is 0.5. And this is DPDB, okay? The change in option value per $1 change in the bond or in the underlying bond value. Duration of the underlying bond is 882, and uh, the market price right now is 97,000 of the bond, okay? 97,000. Uh, and then, so we put into the equation. So this is what duration of the assets minus duration of the liabilities on the balance sheet, but multiplied first by your debt ratio, right? Multiplied by the size of your assets, divided by, what is it? Delta of the option, DPDB, remember, DPDB, right? So again, once again, this is delta of the option, right? DPDB is the change in option price per $1 change in the underlying bond value, multiplied by the duration of the underlying bond multiplied by the value of the bond. Okay, this exactly fits this one, right? Our equation here, and we get how many contracts? 537.62. So we have to round it down to 537 contracts. So put option, right? So long put. Remember why we are taking long put? Again, we don't need any logic. We don't need any analysis of feeling. You take the position based on your interest because you're afraid that the portfolio value will decrease and then your equity value will decrease. Then you are afraid of the decreasing value of something, right? That's why you take a selling position. So you take long put. Long put means you buy the right to sell, right? Okay, so we can prove it here. If you put this into the proof here, 537 contracts multiplied by all the, again, the delta of the option, right? Multiplied by duration of the underlying bond, multiplied by the value of the bond, multiplied by the change in interest rate in concern, divided by 1 plus the original interest rate, you get exactly 209, right? Okay. And how much is the cost? Remember, you're taking a long put position. Long position means you have the flexibility, right? You have the choice. So you have to buy the option. Let's assume that this is the price of the option, right? The price of the option or the premium. 250 per 250 per $100 face value. Okay, so if you take 500,000 put contract, okay, then you need, how much is it? 2,500, right? Of the option, what's that option price or option premium that you have to pay? Okay, so again, this is the number of contract is 537, and the put premium per contract, that put premium per contract is 2,500 in this story because it's like 250 per 100, right? So 2.5%, right? 2.5%. And suppose that you are using this one, T-bond put option. So the size of the contract has been determined, right? Because this is part of an exchange traded option. The exchange traded option, uh, it has been determined by the system, right? So you either take it or leave it, right? You cannot negotiate. So it's like 2.5%, right? Or 250 per 100. And again, if you are taking a long put position in the T bond, right? The contract size is $100,000, right? So once again, because the size per contract is 100,000, so 2.5% of it is 2.5% of 1,000. Sorry, 100,000 is 2,500. Right? So this would be the option price or option premium per contract, right? Okay, so 2.5% times uh, the size per contract, right? So again, once again, the option premium or the option price would be 2,500 per contract, and you are taking 537 contracts. So the cost of the long put is 1.3 million. See, it's not that cheap, right? That's why in the third part of the video series, we saw the micro hedging when we are seeing that okay the option premium per contract is not that big, right? Usually not that big, but if you're talking about a lot of contracts like 537 or sometimes more, it could be 1,000 contracts and so on, you're seeing that the cost of buying or taking a long position is not minuscule, right? Could be quite significant and enormous. Right? Okay, so again, they match one another, hopefully. But now we have the possibility of basis risk, right? The basis risk. Do you remember, right? The basis risk or the hedge ratio. Hedge ratio is always the change in the spot, right, divided by the change in the derivative. In this example, this is the option, right? So the change in the spot world, right, in the change in interest rate in the real world might not be the same or might not be uh, corresponding perfectly with the change in interest rate in the option world, right? So in our previous example, we assume that both interest rates change or move exactly in the same amount, not only in the same direction but also in the same magnitude. But here we'll see an example. So what is it now? 0.92. So you can imagine, right? 0.92 means 0.92. This is like 92 per 100, right? Or 0.92 per 1. So you can imagine, right? So for uh, 1% change, right? 1% change, uh, 1% change in the option world, we have only 0.92% change in interest rate in the real world. Okay, so once again, right? So basis risk. So from here, it's always the ratio between what is happening, right? What is happening in the spot world, in the real world, divided by what is happening in the derivative markets. In this case, option, right? The option world. Okay, so if we are saying the basis risk is 0.92, it means something like this, right? 0.92 per 1. Okay, so what is happening here is that for Oh, let me. Oh, the rate of the rate on the options underlying bond changes by 92% of the spot rate. Okay, so this is the other way around. Okay, so yeah, I think it's less appropriate to say that the basis risk is 92 because now the story is that for every 1% change in the spot rate, uh, the interest rate only changes by 0.92% in the option world. So actually, we should write it like this. So the change in interest rate in the real world, in the spot world, divided by the change in the interest rate in the derivative market. So in our case, this looks like this. Okay. So actually, the basis risk is not 0.92, but it's more appropriate to say that the basis risk is 1.09. Okay. So it's just like what's that? The disagreement about the numerator and denominator. But here's my point here. Right? If we say a hedge ratio or basis risk, usually uh, we are saying it this way. This is the change of anything, right? Change in price or the change in interest rate, right, in the spot market divided by uh, the change in interest rate in the derivative market, right? So the derivative market in our discussion today is option, right? So in our previous example, we saw that we assume that the change in interest rate, right, change in interest rate in the spot market and the change in interest rate in the option world were the same, right? The changes were the same. That's why there was no basis risk in our previous example. But now they're including, we have the inclusion here. We got the information. That's why it is a bit confusing. So basis risk is actually not 0.92, but what actually this example means is something like this, right? So uh, for every 1% change in interest rate in the real world, right, in the spot world, the change in interest rate in the option world is only 0.92%. So the basis risk should be, what is it again, 1.09. So this is more appropriate, right? So it's more appropriate to say that the basis risk is 1.09. So rather than saying that the basis risk is 0.92, okay? So I hope you got what I mean. It's just a disagreement or confusion about which one is the numerator and which one is denominator. So I'm just telling you that this is the more what's that more common form of defining basis risk. It's the change in interest rate in the spot market divided by the change in interest rate in the derivative world. That's why we call it basis risk or the hedge ratio, right? So in the story, again, before we go back to the story, uh, every 1% change in interest rate in the spot market is followed by or is corresponding with 0.92% change in the interest rate in the derivative world, in the option world. Okay, so we go back here. That's why you see the basis risk is here. If you notice, right? All other things are the same, right? The what's that? The whatever it is here above, right? The duration of assets minus duration of liabilities multiplied by the debt ratio first, multiplied by the size of the assets. So we get 230 million here, right? That's the same numerator. Now, what is the denominator again? This is the delta of the option multiplied by the duration of the underlying bond multiplied by the value of the bond or the size of the underlying bond. Now we have basis risk here. Why is it in the denominator? Now you understand, right? Because it's like this, right? So if the basis risk says that for example, uh, for 1% change in the interest rate in the derivative world, the change in interest rate in the spot market is 1.2%. Then it will look like this, right? If it looks like this, then the basis risk should be multiplied to the numerator. Okay, so this is not something to be memorized, right? uh, you don't need to memorize where to put the basis risk. It depends on the story, right? So in this story, what's the story again? 1% increase in interest rate in the spot market, right? In the real world. This is followed by 0.92% increase in the interest rate in the derivative world. That's why the 0.92 is in the denominator. Okay, so this is not something that you need to memorize, right? It depends on again, it depends on the story. Okay, so now we find out that the long put that you have to take, long put position that you have to take increases to 584 from, what's that again? 537. At 537, now you have to take more contracts. You have to take more long put contracts because, again, because of the basis risk, right? The increase in interest rate in the derivative world is lower than that in the spot market, right? Or in the real world. That's why you need more long put positions, right? Okay, I hope it's quite clear about the use of option to hedge the interest rate risk, right? Especially the bond portfolio, the fixed income portfolio. Now, what about the currency risk? So this is very easy. We saw this a lot also in the my discussion, the second part of the video series, or another topic called foreign exchange risk. You can watch that one also. So the number of contracts taken is simply a function of the amount of your exposure divided by the size per contract. So in this story, you see here, the exposure that they want to hedge is 100 million Canadian dollars, right? And then the size of the option contract, right? The size of the option contract, especially if this is an exchange traded option, right, is 100,000 Canadian dollars. So you know exactly that you need to take 1,000 contracts. So you take long call or long put would depend on the situation you try to handle, right? The risk that you try to manage. Uh, for example, if you have assets in Canadian dollars. If you have assets in Canadian dollars, then you'll be quite concerned that the value of Canadian dollars will decrease or the Canadian dollar will depreciate, right? So you are afraid of depreciating Canadian dollar. So that's why you take a long put position, right? Because you have the right to sell. And hopefully you're selling it at a higher price before it declines or before it depreciates. Okay, so this is what you're afraid of, the decreasing value of Canadian dollars. That's why you take a long put position, right? Okay, so let's continue now with the credit spread call option. I think when we discussed the forward or futures contracts, we saw the credit spread forward, right? Credit spread forward. Now we see credit spread call option. So it works in a similar fashion, but this is an option, right? Option means again you have a flexibility whether or not to execute the option, right, or the deal, right? Again, under forward or futures, you don't have the choice, but you are committed, right? You are committed to executing the deal that you have made with your counterparty. But here on option, you have a flexibility or a choice, and very similar. See, if if your client experiences the uh, decrease in quality, then the yield spread will increase. Right? Remember our discussion on this topic using the forward or futures. So if you have the spread right now, for example, the spread means interest rate to be charged on the client, right? Minus maybe a certain rate, interest rate to be charged on uh, maybe prime borrower, right? Prime borrower. This is the prime borrower means the credit-worthy borrower or the good quality borrower, right? So you have the spread here. Let's say the spread is uh, maybe 2%, okay? 2%. So from time to time, the spread might change depending on the quality of your client, right? If the quality of your client declines, right? So the quality drops, then this should be charged higher, right? We should charge it higher after several months. I mean, if we could, we should have charged the client higher. Maybe now the spread has become 4%. So the quality of your client deteriorates in this case, right? Because now this should have been charged higher compared to the interest rate on the prime client, right? But if the quality of your client improves, then the spread might become like 1%. So it's more narrower because the quality of your client improve. So the interest rate to be that should have been charged on that client uh, would decline, right? And the spread would be lower as well. So how you get it, right? So if the quality of your client drops, then the spread will be higher. And on the other hand, if the quality of your client improve, then the spread will be lower. Okay, so using this one, right? Credit spread. Okay, credit spread. So see here. So if your client, see, if your client deteriorates, right, in quality, then there's a possibility that uh, the loan that you have given to the client will not be repaid fully. Maybe the client will have like a financial distress, or maybe it will go broke or something like that, right? But by doing this, what's that? The credit spread option, right? Credit spread option, you earn money, right? You earn money uh, from the contract because of the deterioration of uh, your client quality. All right, just similar to the position under forward or futures, except that this is option. Okay, so see here, repayment performance. You have to again you have to pay for here we have to pay for option premium because you have the choice, right? Whether or not to execute the deal. Okay, so again, once again, this is an option, right? So let's suppose that you take this position, right? The yeah, long call situation, and maybe this is your contract. The option contract says that you're taking the long call at a spread of 3%, right? 3%. So after some time, maybe 6 months, 3 months, 6 months, or whatever, let's say the spread after 6 months is 2%. So obviously you will not execute the contract, right? Because your contract says that uh, the contracted spread is 3%, right? So you let it go But of course, when you entered the contract, you had to pay the premium, right? The option premium. However, let's say 6 months later, the spread has become 4%. So your client does deteriorate in quality, right? So declining quality. Then you execute the contract, right? Because again, your call option says that the spread is 3%. Now the spread is actually 4% after 6 months. So you execute the contract, then you get money from this, right? You get money from this contract. But in the real world, your client might have like a financial distress or might go broke on something else. And the money from here is expected to compensate for the potential loss that you might suffer from the real world because of the decreasing quality of your client, as shown by the higher spread. Okay. So other types, maybe catastrophe, the CAT, catastrophe risk, right? For example, the contract might say that uh, you take a like long call, right? Long call, and the strike price is between 50 to 80, right? The strike price is between 50 and 80. So you get no payoff if the real loss ratio is below 50%, but again, it's capped at 80%. So if it's more than 80%, the maximum strike price is the loss ratio of 80%. Okay, you can see the payoff here. So maximum would be the loss ratio of 80%, but below 50%, uh, you not get anything, right? Because the strike price is between 80 and between 50 and 80. Okay, so we have seen again the uh, credit spread call option, right? Credit spread option, again, and catastrophe risk call option as well. So basically, it works similarly to the credit spread forward, but here this is option, right? Under the credit spread forward, you have to do it, right? Either you get money or you lose money. But here, because this is a long call position, you have the choice, right? Whether to execute the deal. For example, this one, right? If the spread is more than 4% and your strike price is 3% spread, then you execute the deal because again the spread has increased or the quality of your client has decreased, right? But if the spread turns out to be like 2% or anything, then you will abandon the contract, right? You will just walk away. But of course, because of the flexibility, you had to pay for the option price or the option premium when you entered the contract. Okay, now there are special types of options. We have cap, we have floor, and we have the combination of both. We call it color, right? So cap, floor, and color. Okay, so let's see. This is very interesting one, right? So we talk about cap, right? Cap, as the name suggests, is it cap? Cap means the upper limit, right? So usually in the stock market, we have the what's that? The resistance price, right? Resistance price, the floor price. So this is like resistance, right? So cap. So you, for example, you take you buy this position, like the cap, which says that the cap rate is 9%. So essentially, you're saying you take a long position, right? Take a long position at 9%. So if the interest rate, if the no real interest rate within the contract period increases beyond 9%, then you get money, right? So similar to long call position, right? But now you take the cap at 9%. Right? But what about if it's below 9%? Below 9% means, of course, you lose money, right? You lose money because of that. So, uh, okay, so Let's imagine now, okay, 9% cap. Okay, so we have we buy this one for, what is it? 2 years, right? Like 2 year contract, and the cap rate is 9. Cap rate is 9 and 9. So what will happen? In the end of second year, actual interest rate is 10%, and you take a long call position, right, at 9%. So 10% is above 9%, then you get what? You get 1%, right? 1%. So as a long position taker, you get 1% of something, right? Maybe let's see the story. Maybe how much is it? Yeah, yeah. Face value is 100 million, right? So 1% of uh yeah, 1% of 100 million is 1 million, right? In the end of the third year, again, the cap rate is 9%. The actual interest rate has become 11%. So again, you gain 2% because the strike price is 9, right? The strike price is 9. This looks like a long call. Then you get 2% of 100 million of the, what's that, the par value, or the notional value. So total that you will get is 3 million. Pretty good, right? But this is a case where you have the cap rate of 9% and the real interest rates are above 9% in both years. Okay, what about this? It's going down, okay? See here, this is the second possibility, right? The rates have fallen below 9%, right? So the cap seller makes no payment, right? So this is an option, uh, different from the case of inverse floater. Inverse floater means if the interest rate is over a certain limit, then you get money. If it goes down beyond a certain number, then you have to pay. But this is an option, right? An option. So uh, if this happens, the cap rate is 9%, but the actual interest rates are below 9%, then you get nothing, right? You get nothing. Okay. But again, to enter the contract, you have to buy the call option, right? So you have to pay the option value or the option premium, option price, sorry, option price, or the option premium. Okay, so what is the value right now? What's the value? Now we use the binomial. Remember the binomial? We apply the binomial model here. So interest rate is 9%. So we take a long call position capped at 9% because the current market rate is 9%. So it has a two possibility, right? According to our analysts or our researchers, first possibility is 8%. It will go down to 8%, or it will increase to 10%, right? And then in the third year, we have uh, three possibilities, right? From here, it could go down to 9, it could go up to 11. From this one, it could go down to 7, it could go up to 9, right? So we have like three possibilities here. And then we have the probabilities of happening, right? 50%. So spread equally, and then also spread equally here, right? Okay, so what's the value of the option, right, of this cap? Okay, so in, let's say, year what, yeah, year two, for example. So you see here three possible scenarios. in year 3, right? And the cap is 9%, right? Cap is 9%. Okay. So let's see. So you see in the third year, right, in the end of year 3, there are 3 possibilities here. Interest rate is 11% with a chance of 25%. Uh, it might be 9% with the chance of 50%, right? 0.25 plus 0.25 here, 50% chance. And the last one is 7% if with the probability of happening of 25%, right? You can follow. I see 25 here, 25 at the bottom, and 50% in the middle, right? So if we have a cap, I will have a cap with a cap rate of 9%. This option will be valuable only if this scenario prevails, right? Only if this scenario prevails. If the 9% scenario happens, then we gain nothing. And let alone the 7%, right? You definitely gain nothing, right? You have to let the contract go without gaining anything. So the only scenario that will provide money in this example is the third one, right? The 11% scenario here. Okay, so 11% is the only one. So how much will we get? 2%, right? Okay. So the cap rate is 9%, right? And in the at the end of third year, if this is 11%, then we will gain how much? 2%, right? We get how much? 2%, with the possibility of happening is 25%. So we get what is that, the weighted by probability, so 0.5%. Okay, so 0.5, right? 0.5. Okay, so again, uh, yeah, the possibility is 25%, and if the interest rate uh, turns out to be 11% after 3 years, then we will gain 2% because the cap rate is 9%. Right? On the other hand, the other scenarios will not give you anything, right? 9% you will let it go, 7% you will let it go as well. Okay, so 0.5%, right? And then with again 100 million is the size of the contract, for example, right? For example, so 0.5% of the size of the contract. Let's say the size of the contract is 100 million. So you'll get what? 0.5% of, what's that? Yeah, maybe I do it again. Here, we have 3 scenarios here. If the 11%, this will give you 2%. Right? Because the cap rate is 9%, right? But if this is 9%, you gain nothing. You gain nothing, right? Let alone 7%. You definitely earn nothing. But 2% here has the possibility of, 25% of happening. This is 50%. This is 50%. Oh, sorry, this is 25. Which means nothing, right? So the only possibility or scenario that will give you money is this one. So 0.5%, right? Okay, 0.5%. So 0.5%, if the cap size, right, the size of the contract is 100 million, then how much is it? You might earn 500,000, right? Okay, 500,000 here. Okay, so yeah, so the expected payment would be 500,000. The expected value in at the end of third year. Right? So what about the expected value in the second year? So we can get it back here. Okay, so what is the expected value in the second year? So I have to draw again here. So the market value is 9%, right? 9%. And then the second one would be, what is it again? Okay, 10%. And the third one is 11%, right? Because you see here, actually in the second year, we have 8% possibility, but because the cap rate is 8 is 9, so this one will not give you anything, right? And this one we have 11, 9, and 7%. Again, if we find the weighted average, this will be 0, this will be 0, so the remaining is 11, right? So what is the value of expected value of the option in year 3, right? To wait until year 3, that would be this much, right? The 500,000, the value of 500,000 is uh, in year 3. So what is the value right now? So the value of, or the fundamental value of the option in year 3 would be 500,000 divided by, so we find the present value, right? Here, what is the interest rate there? 1 plus 11%. Then to here, 10%. And from here to here is 9%. So the value of the option in the third year, in today's price, today's value is, we have calculated that, how much is it? This one, right? 375,700. So 375,000, okay? 375,000 700, okay? Per contract, right? Per contract. Or for this contract. Okay, so what about the if we again, this is what this is uh the present value of, again, the value of the option in year 3, right? So the value of the option in year 3 would be 500,000, but if we find the present value of it right now, this would be around 375,700, and with the interest rate, right? So one more time, with the interest rate, we see here in the first year is 9% for sure. The second year we have two possibilities, right? 50%, chance that it will be 10, 50% remaining chance that it will be 8. But if it's 8, then there's no value, right? Because the cap rate is 9. And similarly, for the third year, we have 3 possibilities, but the 2 other possibilities will be worthless. So only 11% would be making money for this case. Okay, what about the second? What is the value of the option in the second year? So we see here again the cap rate is 9. The cap rate is 9% here. So if this is 10%, then how much will it give you? 1%, right? Because the long call is capped at 9%. So if the real interest rate in the second year is 10%, then you get 1%. Right? But if the interest rate in the second year is 8%, then you get nothing, right? You abandon the contract. You will walk away without getting anything. So here, 10%. Let me write down there again. So in the second year, if this is 10%, then you get 1%. If it's 8%, you get nothing. Okay? And the 10% means, again, you get 1% because the cap rate is 9. Your contract says that the cap rate is 9%. So if the real interest rate in the second year is 10%, then you get 1%, right? And the chance of happening is 50%. And the other possibility is 8%. But if this happens, you get nothing, right? Because you have the long call with strike price of 9%. This is 8%, you get nothing. But the possibility of happening is 50%. So what is it? One of 50% of happening. So yeah, so 0.005 is it? Here. So yeah, 0.5%. So 0.005, yeah, 0.5%, and this is nothing, right? So if you find the weighted average, this would be 0.5%, right? Okay. So this would be the weighted average benefit that you will get in the second year. And remember, the cap size is 100 million. This is the size in the contract. So how much is it? Yeah, the same, right? 500,000, is it? Yep. Okay, so the value of the option in the second year is also 500,000. Okay, so this happens by chance. Okay, it's not they they are not necessarily the same, right? But again, the option value, right? Or sorry, the option price or the option premium, right? In the second year is supposed to be 500,000. However, if we want to find the market value of it, so see here. Let me draw again, I think. So we know that the value of the weighted average value of the option is 500,000 in the third year. And by chance, right, this is also 500,000 in the second year. So this happens by chance, okay? It's they are not necessarily the same just because of our numbers. So 500,000 based on our estimation here, you see here, right? If we want to find the present value, what is the value right now of the value of the option in the second year? We know that the interest rate here is 9%, and then here is between 10 or 8, right? And this one is between 11, 9, and 7. But we have seen that the previous example, if the cap rate is 9, then this is worthless. This is worthless, and then this is worthless. So when we find the present value, uh, yeah, the present value of the option in the second year. So the value of the option in the second year is 500,000. What is the present value right now? So we have to discount it back. Right. This one here, from here to here, at 10%. And then from here to here is 9%. And we will get, yeah, 400, yeah, this one, 417,000, right? 417,000. So if we combine, right, if we combine the the present value of the first one, this is the present value from the third year. This is the present value from the second year, right? And then we get $792,700. This is the option, what's that? Option price or the option premium. Okay, so again, the 500,000 here has a present value of, how much is it again? 375. Yeah, 375,000 somethings. And then for this one, the present value is 417,000, right? So when we add them together, because the present value of from here to here would be zero because it's 9%, right? You cap it at 9% and the interest rate is 9%, so it's nothing, no value, right? The cap is 9% and the interest rate is 9%, so there's no value from the first one. So if I maybe if you have question why we don't do anything with the first year, so here the value would be zero, right? Why? Because the interest rate is 9% and the cap rate is also 9%. So 500,000, 500,000 and zero. And the present value of 500,000 is 375, right? From the third year, this is from the second year, and from the first year is zero. That's why when we find the cap premium, so 417 is for the second year, this one, right? 375 is the present value of the uh, present value of the option in the third year, right? The present value of it right now is 375. And then the present value from the first year is zero. So if we add together, so we find out that the cap premium or the cap price should be $792,700. So this technique is called the binomial model, right? We saw also in the uh, third part of our video series on derivatives. What about floor? So we have seen what cap, right? Cap. See floor. Floor is the other way around. Floor is like long put, right? It's long put. So it's like this, right? If you have the floor price of floor interest rate of 4%, floor rate of 4%, then you make money if the interest rate declines. So if you long put at 4%, if the real interest rate is 2%, then you get the difference, right? 2%. If the real interest rate is 3%, then you get 1%, the difference. But What if the interest rate does go up? Then you get nothing, right? Because you're taking a long put position. So floor means long put, right? Cap means long call, right? So again, long put position, if you uh, get the floor price at 4%, then you get money if the real interest rate decreases. See an example here. The cap rate is 4, right? The actual interest rate in the second year is 3%, right? 3%. So how much will you get? Long put means you have the right to sell, right? You have the right to sell. So you buy the right to sell. So if you have long put at 4%, if the actual interest rate is 3%, then you get 1%, right? You get 1%. If the size, what's that? If the contract size is 100 million, then you get 1 million. Right? Because again, you have the right to sell it at 4%. But actually the interest rate has declined to 3%, then you get 1%, right? But in the third year, you have the right to sell. Again, you buy the right to sell at 4%. This is the floor price. But the actual interest rate is 2%. So imagine again, right? You have the right to sell at 4%, but the real interest rate is only 2%. So you earn, right? You have the right to sell higher at 4%, but actually the interest rate is only 2% right now. So you get a 2% differential and 2%, let's say, of 100 million of the contract size, then you get 2 million. And in total, you get 3 million. However, again, uh, if the interest rate increases, then you abandon the contract. You will not pay for anything because this is an option, right? So you abandon the contract. This is, once again, this is not an inverse floater. This is a floor. So you gain money if interest rate falls, but you don't suffer any loss if interest rate increases. However, as a long position taker, long put position, as a long position taker, you have to pay for the premium or the option price. Okay, it's just the other, what's that? The opposite of cap. Right? Cap means long call. Floor means long put. Now what about colors? Colors is a combination, a combination. So you take both. For example, here uh, you might take, for example, the uh, cap, right? So you get money, right? So this is like long call. You get money if interest rate increases beyond 9%. Example, right? Example. And if you long put, it means that you're what's that? You buy the floor. This is the floor, right? It's like long put. So you get money if interest rate falls below 4%. Okay, so if you take a simultaneous positions like cap and collar, right? You buy cap, it means you take a long call, and then you buy floor, which means you take a long put position. Then you're seeing what we name collar, right? Collar means a combination of cap and floor. But there's a possible position like this. You buy, for example, you buy the cap, right? So you're taking a long call position, right? You buy the cap. Remember the cap, right? You get money if the interest rate gets higher than 9%, for example, right? So you buy a cap. But uh, now you don't want to pay for the premium. You think that the premium is too expensive, and it is expensive, right? You see from our example, with this example, the cap premium might be like 800,000 or a bit less here, 792,000. So it's quite expensive, right? For 100 million contract. The uh, the call premium or the cap premium is 792,000. So it's quite costly. So you try to reduce no reduce the option premium that you have to pay by selling floor. So selling floor means what? You short put, right? Okay, so uh, if you buy the floor, that like our previous example, right, this one, this is long put, right? Long put position. So the floor price is 4. If the interest rate goes down to 3 or 2, then you earn money because you take a long put position. But if you want to maybe earn some money from the floor, then you take a short position, right? You take the short position of the floor instead of long position. So you earn money a bit from here because you sell the option, so you get the premium. And but here you have to buy the cap, so you have to pay for the premium. So you get premium here, you pay premium here, and it's expected that again the option cost or the option premium could be cheaper by doing this way, right? So see here, the cost of the cap. So you buy the cap and you take long put position, and this is you sell the floor. You sell the floor, so you get premium from selling floor. So see an example here. The contract size is 100 million, right? 100 million, and suppose that you buy the cap, right? You buy the cap at certain level, then you have to pay. This is like uh, how much is it? 0.007, right? The premium at 0.007. Uh, yeah, 0.75%. No, no, 0.79%. This is the premium, right? 0.79, yeah, percent. And simultaneously, you sell the floor. So you sell the floor, right? You take a short, yeah, like short put, right? Essentially, it's like short put. So you sell the floor, okay, with the same notional value or the same contract size at the premium that you get is 0.75% of the notional value or of the contract size. So you pay for this one, right? But you earn money from this one. So your cost is now only 42,700, right? Instead of how much is it? Maybe 70,000, right? If we don't do this, then the cost of the cap would be about 79,000 somethings. However, this could be dangerous, right? This could be dangerous. You can imagine a situation where uh, maybe following our previous example, you buy the cap at 9%, right? So this is the cap that you buy, right? You take a long position in cap. So if again, if interest rate goes above 9%, then you earn money. If it's below 9%, then you get nothing, right? But you have both the cap. So to save some money to pay for the cap premium, you try to sell floor. So you don't buy the floor, okay? Don't you sell the floor? Let's say at 5%. Uh, declines right below 5%, then you will pay because you sell the floor. Okay, this is very different example from the earliest one. Our earliest example on the floor was we bought the floor, so we took a long put position. But now you short put, right? So you sell the floor to make money. So if interest rate goes down, right, or falls below 5%, then you pay, right? You have to pay because you're taking a short position. Okay, so you earn money from this one, right? You pay for this one, you pay to buy the cap. However, sometimes you try to save a lot of money and then you sell the floor at a very dangerous level, maybe here. So you try to increase the floor price. Then of course, if you increase the floor rate and you sell it, then you get more, right? You get more premium to be earned. However, you see how dangerous it is. You are increasing the floor rate, right? Increasing the floor rate means it could easily goes it could easily go beyond or below 8%, right? Okay, so you can imagine, right? Again, to cover the option cost of buying the cap, you try to sell the floor. Again, sometimes you become like too stingy or maybe too greedy as well. Yeah, either or both. Uh, you try to sell the floor at a higher and higher flow rate, and it's very dangerous because if you if you sell the flow rate at, for example, 8 from 5 to 8, then of course the possibility of the interest rate to fall beyond 8% is higher than that beyond 5%, right? You can get it easily here. Then you get more premium, but your situation is more dangerous, right? Very risky. Okay, so this is the way to save some money. Okay, save some money. So you take a long position in the cap, but you take a short position in the floor, right? So if interest rate increases beyond 9, you get money. But if interest rate falls beyond 8, maybe, or 5, or depending on the floor price, then you have to pay, right? But by selling the floor, you get income from the premium that hopefully could help reduce the cost of the option because of buying the cap or taking a long position in the cap. Okay, so I think uh, this is our extensive discussion on option. Uh, it's getting more and more complicated, especially in the real life, because we have a lot of combinations. But uh, again, practice uh, makes it more, makes you more eloquent and also more skillful in doing things. Right? We are not saying that we could get into perfection, but again, the practice, uh, that your daily work in this, right? Maybe someday in the future will really help you understand more and getting even more innovations uh, in the derivative, instruments development. Okay, so I think I will end my presentation and discussion here. If you have questions, you can contact me. And as I said, there will be a lot of new developments, even every day. Uh, a lot of innovations, especially with the advancement of calculus, um, information and communication technology, and also the financial engineering realm. So thank you very much for your attention. Mm, we'll try to meet again for our next topics, right? And uh, we'll continue also with another derivatives instrument and market, which is swap, in the next series. So in the next part of this series. Thank you very much and see you again. Bye.